This is WebAssembly for the backend, and so if you are hoping to hear about browser-based stuff, you're not going to hear it, and I won't take offense if you leave. But even if you're doing that, you might enjoy the trivia of hearing about backend WebAssembly. I'm Adrian from Tetrate, open source late bloomer. I was about like 14 years into my work before starting in things. But I'm currently all in on Wazero, which is a Go-based implementation of WebAssembly runtime, and that's one of the reasons why I have things to say. It's completely Go, like pure Go, not C Go, like 100% Go, no dependencies. And if you like following things, on GitHub, I'm Code from the Crypt, and on Twitter, I'm Adrian F. Cole, and I also am on LinkedIn. But enough about me. So when I looked at how to do this talk, I was thinking about how a lot of the WebAssembly presentations tend to go, and often they go into like, here's the architecture of this and this and this and this, and at some time after you get through all the jargon, you get to learn what it's used for if you get that far. And so I decided to do it differently this time, which is to just go with the relationship between WebAssembly and what you would actually use, and what that. Like all decisions in software and architecture, there's a trade-off there. So I'm not going to do the depth-first explanation of all the jargon. And if you hear some words that you haven't heard before, that's probably going to be comfortable. I mean, it's not going to be comfortable, but it's going to be something well felt. And then if you feel like the context around it was important to you, then you can do like the notes and look at many presentations that can help you link afterwards. But my goal is to get, use the only 30 minutes that we have to get through a lot of architecture and software impact and try to get rid of some of the most common questions people end up having, and books. So service architecture will start. So we'll start from the top and go down. One of the things that you will hear about WebAssembly is that it's an embedded technology, so it's not an RPC type of technology. And the only animated slide I'll ever have in my life maybe is this one, and watch it go. So basically the main thing is that if we're looking at normally how we would do the breaking the monolith stuff for a big application, sometimes you take the code and you break it out into another module, which is a dependency, or you break it out into a service, which is invoked via HTTP or gRPC or whatever. In WebAssembly, you can still do like monolith breaking type of stuff, but at the end of the day, it's actually running right back in the same process as the other things. So it's an interesting way to do modularity while still using exactly the same process. And again, this will feel a little bit uncomfortable because I'm not going to have time to get through all of these type of things. But I do have a link here. For example, there's a project by an employee of a local company, Aqua Security. Tepe there has a Go plugin project, which actually allows you to toy around with defining a service as a gRPC service, but then actually implementing it in WebAssembly, which is kind of cute. And one thing you'll see sometimes is people say like ABI. And if you're a compiler person, you'll be comfortable with that. And if you're like most of the people on the earth, you won't be comfortable with that. But like if you think about API for remote services, and that's a contract by which they communicate, ABI, the binary interface, is how compilers communicate. And it does the same role though. It defines functions that are allowed to be used and stuff. And so if you see that scary 3 letters, just think of it, change it to a P, and you'll probably have about the same relationship that you need. So let's talk about sidecars, which I think is the most ironic part of our modern infrastructure. So if we buy into all these things and we're using like microservices to get rid of monoliths, and then if you look closely enough at a sidecar, they always end up being monoliths themselves. And that's because a sidecar, which role is to offload certain routine tasks like TLS termination or authentication or other things that your app would otherwise have to do, they tend to be like deeply embedded infrastructure code. And so they tend to have a lot of features in them, a lot of config files, a lot of YAML. And if you look at them on GitHub, then you'll find, wow, this is a big monolith. So I'm using it kind of ironically, but it's also reality. One case you can think about, if you've heard of Envoy, which is a proxy that's commonly deployed in like Istio environments, is that sometimes they not only have monolithic tendencies in the code base, but they also have a tight coupling with other infrastructure software. So you'd have to have specifically and only this version and only this version there. And those versions have nothing to do with your application. So when we talk about modularity, it's the opposite of decoupled, right? Or of coupled. So I'm using this to kind of talk about that. Another way modularity comes in Go specifically is that we tend to like static compilation. We like to be able to cross-compile to different architectures and use like the strengths of the Go toolchain. But by act of getting like the statically compiled binary, you're no longer like dynamically linking to things. You still may want to have some things swappable and changeable. So whether you're talking about monoliths that you may write or other people are writing, for example, Dapper's written in Go, this stuff comes up. Let's get concrete. So if you have taken like a mesh type of architecture and using a sidecar to offload responsibilities that would otherwise be in your app, like authentication or TLS termination or cert validation, whatever you may be doing, then your app is pointing to basically this sidecar process, usually localhost, and it's intercepting traffic, and you're instead of sending that directly to the remote endpoint, and vice versa is the case. And of course, it doesn't have to be HTTP, but I'm just using it because most people know that. So in other words, you end up building something, but relying on something that you've installed. So you've moved responsibility into something that's kind of like infrastructureware. And the way we normally deal with infrastructure is configuration. Even though they're romantic notions of infrastructure as code, sometimes they're just like doing YAML for us. And let's say we actually like that idea, but we want to break it down a little bit. So for example, before we have these type of handy processes, we had full control over our whole HTTP lifecycle. And maybe there's a filter we need just a little bit in front of all the rest of them. And that used to be something in our app. But now we can't touch it because it's too far out. And maybe the thing is customizable, but only with Lua or only with something else, and it doesn't quite fit our needs. And you can't convince the infrastructure itself to change just for you. So this is one of those cases where there could be tension. And I'm not saying it's a common thing, but it does happen. And you can tell this has happened because, for example, in Istio and Envoy, they already have like a WebAssembly thing which allows you to customize things in this way for reasons like usually site customizations. They may have common HTTP headers that need to go for a specific site that are not different for the site, but are different than other people. And so if you're using WebAssembly to be able to like make the outer filter customizable by whoever's installed it, then you would have them compiling code and then loading it into it. And the code that's allowed is, well, first off, it would have to be compiled to WebAssembly, which is a safe sandbox environment. And again, I'm using a little bit of jargon, but bear with me. But it also needs to be only using valid functions that are allowed. So for example, in Dapper, they have this interface called HTTP WASM, which basically Dapper is providing you means to access HTTP headers or write static response or things like that. You can only use those. You can't like make outgoing call or start weird things inside of it. And so the goal is to create kind of a safe environment because infrastructure generally doesn't like untrusted code. So if they're going to take some third-party code, there are going to be constraints around that. And the cool thing that you can get out of that is you can have a completely separate lifecycle for those plugins than the infrastructure. So you don't need to get into a lot of convincing of people to like change versions of things because you actually own that version. And to put it visually, if you can imagine you have like a GitHub repository with your app in it, you could also have your infrastructure filters in it too. which are compiled to WebAssembly instead of like normal ELF binary for Go or whatever. And so the distribution of those would be configuration, but you own that code and you can change it as much as you like. And so it brings some more control back to the developer. And I think it's a really helpful thing to allow people to be empowered by infrastructure, but not as constrained as it would otherwise be. And so this thing is actually about Dapper, which is a sidecar infrastructure. I'm using it for a couple of reasons. As an example, one, because it's pure Go, not even Seagull. Secondly, it's using the runtime that I work on, and it's released. This month has this stuff I'm talking about. So it's not like vaporware. So let's move down the stack a little bit. I got 20 minutes left. So I've had a similar talk to this before, and I would get this question like, what about containers? What about whatever? And especially coming up now because there's a lot of buzz around like Docker and WebAssembly and what does that mean? And of course, Docker, a lot of that infrastructure is written in Go. So let's talk a little bit about containers. And the TLDR is that WebAssembly is aiming to be just a leaner layer, effectively. And the reason that it could be leaner is that container images are pretty much, first and foremost, platform specific. Now, you have a lot of flexibility. You can run a different platform than you are. If I have a Mac, I can run Linux containers on it, with container images. There's a little bit of complexity there for Windows, but, we'll put that aside. But at any rate, your container images are built for a specific operating system and architecture. Architecture we're only really hearing more recently because there's a lot more times that someone gets a MacBook when it's got an M2 processor in it and it's ARM-based process. And it was easier before because everybody just had Intel. But now we're ending up with deployment environments, which might be, AMD 64, ARM 64, RISC-V, you name it. And so container images must match those or else you'll get weird errors when you try to run it. But there's also a need for an operating system too. Now, we do have a lot of wonderful developments over the years to make both nice base layer images, which are tidy and lower surface area, but even Scratch. And if you're using Go, one of the most awesome things about Go is that if you don't use Seagull, then when you compile your binary, you can use from Scratch as the first layer of your image. And that not only makes it small, but it also basically removes the operating system part of it from like your complexity concerns. And it doesn't really remove everything. It just moves it down to the kernel level. So it's basically Linux. And that system call level is actually where WebAssembly would match. So WebAssembly is a platform agnostic virtual machine technology. And so when you get to the point where you need to run something, you need to understand where it hits the road. Well, WebAssembly has no operating system. And so if you believe that WebAssembly has no operating system, if you're able to compile it, then it can't have an operating system dependency. And so that's one way that you can kind of like get your head around it. Okay, all right, I believe that. And if it doesn't even have an operating system, how could it have a libc dependency? So you can't put like libc directly on top of nothing. So then you're like thinking, okay, well, actually, by virtue of if I can compile something to WebAssembly, I've actually washed out all of its dependencies. And so it's got a really cool trait to that. And then if you think about Docker all over again, which there's lots of famous tweets retweeted, several years later, because this could have been done several years ago, that you have this write once, deploy anywhere type of thing where wherever you manage to compile it, then you could run it somewhere else as long as it can run WebAssembly. So in this case, this is actually very close to a literal Docker file for WebAssembly, where you would start from scratch, which means nothing except for the kernel. And then in this case, we're putting Python on it. And we're putting the WebAssembly compiled binary, which they have a .wasm extension. That's how you know it's WebAssembly. And then Python's an interpreter, so you need to throw its like a all of its, lib directories and things on the same thing. And then if you're able to run that entry point, then effectively there you have like a much more portable Python. Some people would be quick to note that like, look, it's smaller. And then they'll say here like 12 megs instead of 60 megs for Alpine. But let's be real, like WebAssembly doesn't support a lot of things. So if you've had problems with like limited operating system distributions, you'll have even more of those with WebAssembly because it's a constrained environment. So for example, it can't make outbound calls, so it can't use like PyPy or anything. So that's why I say it's not mature. And I will, if this was a long talk, I could get into many, many reasons about that. But let's just say there's some sort of functionality gaps, and so don't get too excited and think like I'm going to like recompile Kubernetes as WASM. If you wanted to do what that is, what's happening in the Docker world right now, which is try to make effectively WebAssembly another basically another architecture, if you think about it, then you can still do that today because WebAssembly runtimes exist. And so there are a few popular ones. There's Wasm Time, Wasmer. The one I work on is Go. So people who like Go might use it, but you don't have to. But you could, because Go is pure, because Wazir is pure Go, it can run on Scratch. So you could just like copy its binary there and then do exactly the same thing. And the main thing that you would find is that you're actually having to put things that look like Docker commands as your entry point. And it's because that WebAssembly is a virtual machine. You're having to kick it off. And so it just looks a little bit confused this way. So I think one of the best benefits for the work that's going on in containers is to allow you the WebAssembly abstraction without seeing too much about how it actually works. That's I think the main idea there. Let's move down again. Application architecture. So let's talk a little bit more about this being embeddable. And WebAssembly first will hit a point of relevance to you if you're in this decision process of whether I fork a subprocess or whether I do some Seagull or something like that for foreign function interface. Of course, we also communicate apps in different ways, RPC and things. But if you have code that you want to run in a local feeling way, usually you're thinking about which is compiled from another language. Usually you're thinking about like either forking a process like osexec, CMD, or you're doing a foreign function call with like import C and then putting some stuff in there. And if you don't feel comfortable with me babbling about like import C and putting stuff in there, don't worry, because that means you don't have to worry about that yet. So just move on. But if you are interested in these sort of like relationships and some of the problems that you have in these decisions, there's a pretty interesting YouTube video of a presentation from Christina Spang, which is subprocess to FFI. And even though it's about Python, it's like completely, almost exactly the same for anyone who has the same problem of making a choice. And if you're thinking about like foreign functions, like I'm importing a C library, there's many, many excellent content if you just like search for Seagull is not Go and throw it in YouTube and a bunch of things will come up. And these slides I'll put online, and of course there'll be links there for you to look at too. But if one thing you can think about as far as WASI, which is the system call layer of WebAssembly. So when I say system calls, I'm thinking about like open file, close file, clock get time, things like that layer. So WASI is sort of like it can be seen as a safer version of OS exec. And so this is a real life application, Nuno Crucis. You can't see the link here, but again, I'll give it to you. But Nuno has I don't know if it's like a hobby project or what, but it's basically trying to make your own Photoshop and only Go, because why not? And one of the things that's interesting is you still get to a point where you would prefer to reuse certain software just because it may be like annoying to just rewrite everything. And so there's a re-rendering library in C called dcrawl, so dcrawl.c. And it turns out that that thing can be actually compiled to WebAssembly. So Nuno previously was using Seagull for that. And one of the problems that he had was that if Seagull crashed, because dcrawl is a little bit buggy, it would take out the entire process. And so you can't really like take a nice error message and give it to the user because it's just dumped your whole process. And because WebAssembly is sandboxed, it's a lot safer. And one of the ironic things was that this allowed him to run like buggy software safely because it can't crash. I mean, you could still do programming errors and panic things, but you're not going to crash. And this, I'll give a quick overview, is that when you have something like a main function in any language, including Go and C, in WASI, in the syscall world of WebAssembly, it will be compiled to a function called start with an underscore in front of it, because we're cryptic. And then if it's doing its normal life cycle of starting up a main function, you have it calling things like get the arguments and maybe read input and write output. But unlike command.exec, where command.exec, you can substitute things like standard in and standard error. You can put those as like byte buffers. It's fine. But you can't like swap in a virtual file system for it. You can't force the command underneath to like use another file system. You can use a temp directory, but you can't fake its entire system. So one of the ways that you can tell that a WebAssembly is a little bit different is that you can actually completely change how files are interacted with that process. And that's really cool for performance, and it's also cool for just sandboxing security and all that, because you don't even have to put a file system there. In the case of this app, Nuno is just using a byte buffer and faking it. So it's quite cool. So anyway, this is cooler code than I write, so take a look at it. And then if we're looking at foreign function invocation, usually we're doing this dance where we're like allocating memory and then freeing it at the end of the call and then passing some pointers around and all that stuff. And in short, the main things that are different in WebAssembly from like Seagull is not just the lack of capitalization, because when you do C calls, there is a capital C is the name of the package. But also, one, you're not using any pointers. Like WebAssembly can't see pointers from Go. It can't. There's no way it can do pointer arithmetic and mess you up. That's how it can't crash you. One of the reasons. The other thing is different is that in the Seagull integration of Go is actually quite tight, and it can, your IDEs can help you. The compiler can help you. The functions would actually be something you can call, and the compiler can check. In WebAssembly at the moment, because it's handled at a library layer, it's you're going to be looking up a function and then passing it. The compiler can't check it for you, so you'd have to pass those parameters. Now there are people who do codegen for that, like not integrated with Go build, but like normal codegen. But at the end of the day, it's dynamic. You can dynamically change it while the process is running if you want to. And so that's a lot different than Seagull, because the signatures are much more fluid. And this, again, is Nuno. Actually, this is SQLite. So Nuno's, one of his hobby projects is to get SQLite working inside of Go without rewriting SQLite or using Seagull. And so then I asked why. And so the gist of it is that you don't always want to rewrite everything. It's not always a good idea, especially when it's talking about orders of 100,000 plus lines of code, which aren't like poorly written. So there's a lot of things out there. And again, this content will be here for you to refer to later if you need it. But you will find that there are code outside of the Go ecosystem that are well worth using. Now, I was talking about polyglot there, using C from inside Go, but if we know, actually Go doesn't have like a really nice plugin system right yet. I mean, you can say that there are ways to do it, but it's not particularly safe either. Aqua Security Trivi, which is a big Go CLI to do vulnerability and misconfiguration scanning. They want to be able to like reduce the tension, because if you're thinking about vulnerability scanning, there's a lot of things that should be configured. Like, is this CVE actually valid for my site or not? You don't want all of these things. You maybe have your own special vulnerability that is not public yet, and you want to run it. So vulnerability scanners are one of the type of things that are like perfectly well fit for WebAssembly, because you would see that people could use external code to either change policy decisions or actually implement new policy. And so in this case, both the CLI, which is a monolith, and the plugins are both Go programming language, but using WebAssembly to allow dynamic loading. And using, if you've heard of like OCI repositories, it's sort of repositories that Docker uses to distribute images. That's the usual way people distribute WebAssembly also. You see TinyGo pop up in WebAssembly a lot, because TinyGo has some more like native-like features when it compiles to WebAssembly than Go's compiler at the moment. I'll get more into that later. So there are a lot of difficulties still if you're using WebAssembly, even if you can manage to get your head around where I would use it. And the one thing I mentioned is that you may end up needing a different compiler depending on what language you're using. So if you're using Go, currently most people would end up using TinyGo instead. Performance is way all over the place. So luckily Go has benchmarking tools built into it. And one of the neat things about WAZIRA being written in Go is you can actually use it, and people do use it, to benchmark their WebAssembly, even though the WebAssembly was written in Rust or something, because the benchmarking tools are really cool in Go. But let's remember there are other ways to polyglot too. Like the things that I mentioned about like working processes and Seagull and RPC, they still exist. So there's no imperative to always use WebAssembly. But if you start to use it, it has some interesting things, but it also has some difficulties, and most of them are around the rough edges of any new technology. So again, this is 30 minutes. I can't get into all the points, but let's talk about like what's next for Go. Go is a little bit behind. Like one of the common complaints about Go and WebAssembly is it's not as advanced as Rust is, which makes sense. Basically, the people writing WebAssembly are the same people writing Rust. But we still could do better, and we are working towards it. And so a couple of years ago, Go already had WebAssembly support. It's just that it was limited to the JavaScript model. So the operating system of Go is JavaScript. And the problem for that, technically speaking, is it's a lot of thrashing of stuffing things through a JavaScript object model back and forth and back and forth. A very simple way to think about it is like in normal programming, you have like real numbers, and then JavaScript, you've got the weird floating point thing. So it extends beyond that too, with having to force memory copies everywhere. It works fine for Node.js and browsers, but it's not like ideal for backend. So TinyGo actually has a better model for that, and there's a plan to do the same thing in normal Go. Johan Brandorst is actually recently proposed this. It had so far, I checked yesterday, it's like 52 thumbs up. Accepted proposal for discussion next week in Go, and no drama on the issue, like none. And so I hope it works out. So anyway, that's all I got. I know I'm talking fast and there's a lot of stuff here. You're going to get the slides. WebAssembly hits a lot of different parts of the architecture, and I hope that I showed some of the ways that it does that from like top to bottom. As if you're a Go developer, you're probably going to see these things as opportunities if you're forking processes or you're already using Seagull. If you start to use it, you'll find some tricky things. There are some talks that get into the details a lot better. I have links here, and if you want to talk to me after this, feel free. So thanks for attending, and yeah, hope the rest of you do as well. If folks want to have a question, I can take one until they kick us out.
What is the status of running WebAssembly containers in Kubernetes?
So the question is, what's the status of running WebAssembly containers in Kubernetes? So, I mean, basically, I don't have it with me right now, but Red Hat's doing a lot of work in that area, and they have like so many different projects with so many strangely named things. But it's actively done because Kubernetes already has the Crustlet stuff, but crun, which is underneath of like all of the container stuff, already has integrated WebAssembly in 3 different runtimes right now. And it's like super being pushed to do things. And so it's not just Kubernetes, but also some of the cloud offerings. I heard somebody telling me yesterday, like Azure is already moving in some direction to do native WebAssembly integration. Okay, thanks.